Now we start our exercise 2.6. Question 1. Find f dash x or f prime of x. First part is f of x is equal to e raised to the power square root x minus 1. Before we start this question, first we recall our formula which are using in this exercise. There are two type of functions involved in this exercise. First one is exponential function e raised to the power x, and the other is natural log of x. First we discuss these two functions. We have to differentiate a function like e raised to the power f of x. The derivative of such a function e raised to the power f of x will be e raised to the power f of x, and then derivative will apply on function f of x. So this is actually a formula to differentiate a function, or you can say an exponential function, such that e raised to the power f of x, then the derivative of such a function will be e raised to the power f of x, and then derivative will apply on this function, which is in power actually. And the second kind of questions are like natural log f of x. Then derivative of such a function will be 1 over f of x, and then derivative will apply on f of x. So this is actually derivative of a function involving log or natural log specifically. So derivative of natural log f of x will be 1 over f of x, and then derivative will apply on a function f of x. So now we explain these two formulas with the help of questions. So we have our first part, f of x is equal to e raised to the power square root x minus 1, and then now we have to differentiate these functions. Solution: so differentiate with respect to x, derivative will apply both of these two sides. So left hand side will become f prime of x, and on right hand side when derivative will apply, this is actually like derivative will apply both of sides. So d by dx f of x, and derivative of e raised to the power square root of x minus 1. Now to comparing these two formulas 1 and 2. So this is of the type of formula 1, which is actually e raised to the power square root x minus 1. So by consulting these formula, e raised to the power f of x will be as it is, and then derivative will apply on f of x. So you can see that here f of x is square root x minus 1. So when we go to differentiate this function, then that will become e raised to the power square root x minus 1, and then derivative will apply on this function, which is square root x minus 1. Now f prime of x will be e raised to the power square root x minus 1 will be as it is, and derivative will apply on this square root x minus 1. Derivative will apply separately on both of these two terms. So square root of x, when we apply derivative on this function, that will be 1 by 2 by using power formula, 1 by 2 x raised to the power 1 by 2 minus 1, which will be minus 1 by 2, and derivative of 1 will be 0. So finally we have e raised to the power square root x minus 1. This 2 will be as it is, and here x containing a power minus 1 by 2, when we shift into the denominator, that power will become positive 1 by 2 and can be written as square root of x. So finally we have derivative of given function is e raised to the power square root x minus 1 divided by 2 square root of x. So again we recall this formula, or match this question with this formula, just to differentiate an exponential function containing e raised to the power square root x minus 1 or e raised to the power f of x, we just have to when we just apply derivative on such a function, that will become e raised to the power square root x minus 1, and then derivative will apply on this function, which is actually 2 square root of x. So part 2, f of x is equal to x cube into e raised to the power 1 over x. So actually this function is a product of two functions actually. One is x cube and other is exponential function e with power 1 over x. So when we apply derivative here, then we use our product rule of differentiation. Solution: differentiate a given question with respect to x. So f prime of x will become x cube will be as it is, derivative will apply on e raised to the power 1 over x, plus e raised to the power 1 over x will be as it is, and derivative will apply on x cube. Just to use our product theorem here. Now the next step will become f prime of x is equal to x cube will be as it is, derivative of e raised to the power 1 over x, as we discussed in our previous part or in our formula, that derivative of exponential function will be e raised to the power 1 over x will be as it is, and then derivative will apply on this function which is appearing in exponent or in power. So that will become e raised to the power 1 over x, and then derivative of power function which is 1 over x, plus e raised to the power 1 over x will be as it is, and derivative of x cube will be 3x square, simply using our power formula which is 3x square. Now simplifying this one, f prime of x will be x cube e raised to the power 1 over x into derivative of 1 over x is just minus 1 over x square, simple algebraic function. You can also differentiate by using like d by dx of 1 over x, which can be written as x raised to the power minus 1. So that is actually minus 1 x raised to the power minus 1, which is minus 1 x raised to the power minus 2, and finally that can be written as minus 1 over x square, which is this one actually. So derivative 1 over x is minus 1 over x square plus e raised to the power 1 over x as it is, and this 3x square. And by simplifying this x cube with x square, that will become just x, this minus will be here, and e raised to the power 1 over x as it is, and this again a second term again will remain same, 3x square e raised to the power 1 over x. Now just taking a common factor x and e raised to the power 1 over x, which is this one, we have left here 3x by taking common e raised to the power 1 over x and this x. Just we have 3x, which is this one, and then from here when we take to common x raised to the power 1 over x, we have just minus 1. So finally the derivative of a given function will become x e raised to the power 1 over x into 3x minus 1.